let's consider the multi-stage experiment without replacement. So when you draw a ball, for example, you don't pre-back, right? There's no replacement. So let's take a look at a few examples here. Suppose two balls are drawn one by one without any replacement. So in this box, you can see two white balls and one black ball. Okay? And my question is, draw tree diagram and probability of outcome. So we're gonna consider all of the outcomes when you draw two balls one by one without replacement. So you can think about, oh, for the first draw, you can have either white or black. If you got a white ball, you're not gonna put it back. So there are two balls left, but one is black, the other one is white. If you draw black out, you're not gonna replace that. So there are two balls left. So you need to think about those two different outcomes there. Okay, so what I'm gonna do here is I'm gonna use this Jamboard, and I will help you to draw a diagram there. Again, you can always pause the video and have your own drawing there. Okay, I strongly encourage you to do that. Okay, so let's take a look at this example and think about the first draw, and you can also think about the second draw, right? So first draw, you can either have black or white, right? What is the probability to get black? There are three in total, but there's only one black, so it's 1/3 of the probability to get black in the first draw. How about the white ball? You can draw white ball in the first draw, but there are two, so the probability to get white ball is 2/3, right? Now let's consider the second draw. Think about this. If you took this out, you don't put it back, so there are only two white balls. So you can think about the outcome of a black ball as 0. It's not gonna happen, right? And you can have white ball, but think about it, you don't have any more black, so there are two left, and there's no black, so it's gonna be 0 of 2, or that's same as 0. To get white ball, it's certain because there's no black ball, 100%, you're gonna get white ball. So 2 out of 2, or that's 1, right? If you got one white ball at the beginning in the first draw, in the second draw, you can consider getting black or white again. But there are two left, and one is black out of 2, and one is white out of 2. So we can think about both probability is 1/2 and 1/2, right? So what is the probability to get black for the first draw and black for the second draw? It's 1/3 times 0. So we can think about another column with a probability of, how about total outcome? You can do 1/3 times 0. This is when you can have, two black. It's not gonna happen, right? How about you have black for the first draw and white for the second draw? To get black for the first draw, it's 1/3. To get white, it's certain, so times 1 is 1/3. How about here? First row is white and the second row is black. To get white for the first row, you got 2/3 of probability, and for getting black for the second row, it was 1/2. So you can simplify this and get 1/3. How about here? White. You have 2/3 of a probability to get white in the first row. To get white again in the second row, it's 1/2 of probability. You can simplify these two again, getting 1 by dividing both by 2, and you get 1/3. So when you add all of these four outcomes together, you're supposed to get 1, right? You can see that 0 plus 1/3, 1/3, 1/3, 1/3 makes 1 as the total. So you can always check that way. Okay, so that's how you can draw the diagram, tree diagram. The denominators of the fractions in the second row. So let's take a look at the second row here. The denominators are 2. All of these are 2. Why? Well, we can consider the first row. We have denominators as 3. All of them is 3. Why? Because there are 3 balls. In the second row, 1 ball is out. It's not replaced. So there are only 2, right? That's why. Because you don't replace it. What is the probability to draw exactly 1 black ball in the two draws without replacement? The same problem, okay? So you're just gonna consider the probability to get exactly 1 black. Which one shows exactly 1 black? This is 2 black, so not that one. But this one, 1 black and 1 black. These two cases, right? So we have a probability of 1/3 and 1/3. So 1/3 and another 1/3. So you have 2/3 of a probability. Okay, let's move on to the next example. So now, in this figure 23, you are given probability, the letters there. Okay, so you have 11 letters in the box. Some letters are repeated, like B. You have 1 B, 2 B's. You also have one, let's see, how many I's? You have 2 I's, and so on and so on. You can find more probably. I don't know. Let's take a look at that later. Suppose 4 letters are drawn at random from the box, 1 by 1. Here's the hint. It's 1 by 1. 1 by 1 without replacement. So let's highlight these. Okay. So you can think about this as multi-stage experiment without replacement, right? Okay, so what is the probability of the event consisting of the outcome B, A, B, Y with the letters chosen in exactly the order given? So you need to consider the given order. So let's think about getting B at the beginning. Getting B at the beginning. You need to think about that as what? You can count how many letters in the box are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are total 11 at the first draw, right? How many B's are there? We have 1, 2 B's. So to get B at the beginning, you have 2/11 of probability. Now you need to get A. But think about it. You got either one of them, right? So there are only 10 left because you're not putting that B back here. So let's suppose this one is out, right? Then there are only 10 of the letters. Now you need to get A. There's only one A, so it's 1/10 of probability. Next letter has to be B again, but there's only one B left. And how many letters are there in total? There are only 9 letters as total. So next, to get B, the probability to get B in the third is 1/9. Now you need to get Y. How many Y's are there? Only one of them there, right? Only one of them there. After getting B out, there are only 8 left. So you can see the denominators decrease by 1, right? So what's the probability to get B, A, B, Y in this order? You can just multiply them together. Then what do you get? You have 2 times 1, 1, 1, 1, which is 2. 11 times 10 times 9 times 8 is 7 times 920. Or if you were like me, I would like to simplify from here rather than dividing everything by 2 from the product here. So I will go with this. I want to keep 10 because multiplying by 10 is so much easier. And I will go from here and do 9 times 4 is 36 times 11 times 10, and then you will get that same from, simplifying here. 3,960. Okay, so that's how you can solve the problem. All right, one more problem for you guys. On a quiz show, a contestant stands at the entrance to a maze. So this is the entrance. So let's draw a person there. The contestant is standing here at the maze, at the entrance of the maze that opens into 2 rooms, room A or room B. The master of ceremonies assistant is to place a new car in one room, either room A or room B, and a donkey in the other. The contestant must walk through the maze into one of the rooms and will win whatever is in that room. So either a car or a donkey, which one do you like? Well, if you like to have a donkey, you need to decide which one can be the donkey using the probability, right? If the contestant makes each decision in the maze at random, in which room should the assistant place the car to give the contestant the best chance to win the car? That's our question here. So let's consider, okay? And let's take a look at from here. I'm gonna use different color. How about this one? Okay, so from here you have 1, 2, 3 different choices. So to go this way, you have 1/3 of a probability. To go this way, you have a 1/3 of probability. To choose this way, it's 1/3 of probability. Let's take a look at this one. You can go here, but you have 2 more options. So to go this way, you have another chance, 1/2 of the chance to go to room A, right? So to go to room A, let's say that's 1. To go 1, you have 1/3 times 1/2, which is 1/6, but you land on room A. Let's take a look at the second choice. How about here? So this is another 1/2 of the chance, but you have another chance, you need to decide which way to go again. So to go this way, you have another 1/2 there. So when you multiply that together, 1/3, 1/2, and 1/2. Let me write that. 1/3, 1/2, and 1/2. You get 1/12. You still land on A, right? This leads you to room A. How about this one? Same probability, 1/3, 1/2, 1/2, but you land on room B. So that's, I would say, number 3. The same thing, but you land on room B. How about the 4th outcome that you can consider going here? So you can take this way, right? But after this one, you have 2 choices. So to select this way, you have 1/2 because there are only 2 different outcomes to choose from. So if you go here, let's say that's 4, that's 1/3 times 1/2. So 1/3 times 1/2 is 1/6. You land on B. Let's consider this one as 5. It's the same thing as 4, right? So you have 1/3 to choose this way, and then choose this way 1/2. So that's same, and 1/6, you land on B again. How about this one? This one is 6. That's still room B. We can say you are still in room B. But let's consider how you can get there. So you need to choose this way first, which is 1/3, then you go this way. And to get that one, you have 2 choices. So to select this one, you have 1/2 of the probability. From here, you have another 1/2 of probability. So you have 1/2 and 1/2. So say that again, 1/3, 1/2, and 1/2, which is 1/12 in B. So how about this one? It's the same thing as this one, right? This is 7. So 7 is also 1/12, but you land on room A. The last one is going here. That's the 8th outcome. So the 8th outcome should be you choose 1/3, 1/2, and go directly here. So 1/3 times 1/2 is 1/6. That lands on A again. So let's see what's the probability in A and the probability in B. So you can just add all A's together, and you can add all B's together. So to land on A, you have 1/6 plus 1/12 plus 1/12 plus 1/6. If we add them together, I have 2/6 and I have 2/12. There are several ways to, you can change, the denominator the same, so change this to 12s, or you can simplify that already and find the common denominator again. Either way is okay. So if you're changing 2/6 as 1/3, and if you choose to simplify first, so you got 1/6 there, you can change both to the denominator of 6 by multiplying this by 2, then numerator by 2 as well. So you have 2 times 1 plus 1, which is 3. 3/6 is can be simplified as 1/2. Hey, then without even calculating, by adding these B's together, we get to know, to get B, it's also 1/2. So what's our conclusion? It doesn't matter where you put the donkey or cart, because landing on A and landing on B has the same probability. Okay, now let's move on to conditional probability. So let's think about conditional probability. Suppose we toss a fair coin 3 times and consider the following events. Think about getting a tail on the first toss as event A, and event B is getting a tail on all 3 tosses. When you toss a fair coin 3 times, so you have only one coin, but you are this is not what is it, Jamboard, so I cannot draw, but you can consider A as getting a tail on the first toss. So you toss it, you can have either tail or head, so getting a tail should be 1/2, right? How about B, getting a tail on all 3 tosses? The first one is 1/2, but that doesn't affect the second toss, right? So getting a tail on the second toss is also 1/2. And those 2 cases don't affect the third toss, right? So you can have 1/2 of the probability to get tail again, because first toss doesn't affect the second one, and first or second toss doesn't affect the third toss, right? So you can think about probability of B getting a tail on all 3 tosses as 1/2 times 1/2 times 1/2. So you have 1/8 there. My question is, if event A has occurred already, we know that, how does that change in probability of B? Well, it matters because we already have counted, probability of A. So if it is already decided, you can just consider the second toss and third toss, right? So yeah, it changes as what? 1/4, because you don't have to consider the first toss, but just consider the second toss as the tail, that is 1/2, and third toss should be a tail too, that's another 1/2. So 1/2 times 1/2, that makes 1/4. So event A has already occurred, then you don't have to think about the first toss. Just consider second and third. To get tail on both second and third toss, you get 1/2 times 1/2, which is 1/4, right? So this is conditional probability, and we use notation as this. So we are reading this as a probability of event B given event A. Probability of B given A. Okay? Alright, so this is given, that's the condition, and you need to find the probability of B given that condition. Okay? So in this case, let's say probability of B getting a tail on all 3 tosses, given the first toss is already a tail, which is 1/4. How do we find it? This is the formula. So remember this. Probability of P and B given probability A. Okay? So remember this. Highlight that on your notebook. Okay. So knowing that, let's solve this problem. I think I have this in my Jamboard. There we go. So I can write it. What is the probability of the event of rolling a 6 on a fair die if, so it is a conditional, we get to know. If you see if or given, this means it's conditional. Conditional, and we know this is given, right? So we are looking for probability of getting rolling 6. Rolling 6. Let's define the event of rolling 6 as A, and the roll is an even number. So the roll is even number, that as event B. Then we know probability of A given B is what we are looking for. So probability of getting a rolling A given the rolls, the number in our roll is an even number. So it's a conditional probability, right? How do you find that? Probability of A and B over probability of B. So what is the probability getting A and B? So when you roll 6, and at the same time it should be even number. It should be only 6, right? So there's only 1 out of, what's the total outcome there? Sample space. You can have either 1, 2, 3, 4, 5, or 6. So there are 6 outcomes. So 1/6 is probability of A and B. What's the probability of B? If we know that the roll is an even number, so what is the probability of getting even number? From 1, 2, 3, 4, 5, 6 to 4, 6. There are 3 of them. So let me erase that. This is 3, 6, right? So 3 numbers are even numbers out of 6 numbers. So you have 1/6 over 3/6. Fraction over fraction. Thinking back to the fraction number from Math 235, you can get to know that's the same as 1/6, the numerator divided by denominator. Divided by denominator. How do we do division of the fraction? You keep the first number, you can multiply the reciprocal, so 6 over 3. Then you can simplify this by dividing both numerator and denominator by 6. So you have 1 left. 1 times 1 is 1. 1 times 3 is 3. So the probability of A given B is 1/3. Okay, we have 2 more problems for you for today. First one, a math teacher gives her class 2 tests. 25% of the class passed both tests and 45% of the class passed the first test. What percent of those who passed the first test also passed the second test? This is also probability of conditional. So we can think about conditional, but what is a condition and what probability are we asking? Are we looking for? So you can see that the given one is what? It says a math teacher gives her class 2 tests. 25% of the class passed both tests. So both tests is A and B, isn't it? So probability of A and B, both tests, test A and test B, is 45%, which is 0.45. Given of the class passed the first test, what percent of those who passed the first test also passed the second test? Given first test is already passed, so first test is what? 45%. Oh, I put the wrong number, didn't I? Yeah, 25% of the class passed both, so both are 25% and 45%. I need to separate this here. And 45% of the class passed the first test. Given first test is passed by 45%. So it's 0.25 over 0.45. If you want to use a calculator, you are okay. You can do that, or I strongly encourage you to just calculate without the calculator. In that case, to make it simpler, you can multiply both by 100. So you can move the decimal points by 100. Do the same thing down here. Then both are divisible by 5. So you have what? 5, 5, 25, 5, 9, 5 ninths, right? 5 ninths is about 0.56, which is 56%. Okay, how about here? Second problem. A math teacher gives her class 2 tests. Again, 25% of the class passed both tests. Okay, so we got both as 25%. Oh, hold on. I put the same question, didn't I? So, hold on. Let me pause this. Okay, so next problem is the probability that it is Friday. It is Friday and that a student is absent is 0.03. So we have 2 different cases here, right? 2 different events. So let's say probability that is Friday. We can put that as F. It doesn't matter, right? And student is absent as how about probability of A. So we are given the probability that it is Friday, and that's the key, right? So probability of F and A is given to you, which is 0.03. Since there are 5 school days in a week, the probability that it is a Friday, so probability of Friday is 0.2. What is the probability? Here's the question. What is the probability that a student is absent? Student is absent given that today is the Friday. So this is the question, and we know how to solve it because it's a conditional. We know we can use probability of A and F given it is Friday, probability of F, right? We already have every number here that we need, so we can just plug it in. Probability of A and F, or F and H, the same thing, so 0.03 over 0.2. To make it simpler, we can multiply both by 100, right? Then you get 3, multiply this by 100, you get 20, which is exactly 0.15. You can do 3 divided by 20 to get that, or you can multiply both by 5. Then 3 times 5 is 15 over 100, so it is 0.15. Or you can say that's same as 15%. Okay, that's it for section 2 of chapter 9. So you are able to solve all the problems in my math lab. Have a great week, guys. Bye.